And this video is 3.3, section 3.3, the first video, and we're going to talk about getting information from a graph. So a complete graph can actually tell you almost as much as a equation, and in fact in some ways it's easier to get some of the information from it. So let's look at a graph. So in this graph, we don't have a equation for it, but we can still tell the a lot of the values from it, right? So like here, if we look at when x is 11, and I use the vertical line because we're looking at x, right? So x is 11, we look up to see how far up y is, and y is 8. So we know that f of 11 is 8. And f of 10 is 5, because we're looking right here where that intersects, right? Now, it is true that my graph is not accurate enough to tell exactly what some of these are, but we could certainly approximate that, this is probably about 3 2/3 or something like that, right? Or here we probably have like 2 1/4 or something like that. So maybe at 5 it's 1 1/2. So we'd be estimating because my graph isn't accurate enough, but if we got a more and more accurate graph, then that's more and more information we'd be able to get from this graph. So we can always tell then by looking at x, whatever our x is, and we look at where it intersects the y, and that would be the y value. So the height of the function, that's the value of the function, that's the y value. Now, there's other stuff that we can tell from this graph, and that's the domain. So if we look on here, and I'll use my vertical line again because I want to look at what's happening with x, right? There is nothing out here. We don't get an answer. We don't get anything on this graph until we get to -6. And at -6, now the graph exists, right? And it still exists. We move on up. X is up to 0, and then x is positive. It still exists. It still exists. It still exists. And then, oh, right here at 11, that's like the end. If I go farther out here, it doesn't exist. But it exists here where x is 11. So that tells us what the domain is. Okay, so I could say the domain was the interval from -6, because that's where it started, right, up to 11. And that's the domain. And I get that from the graph. I don't get that from an equation. I get that from the graph. Now, let's look at what the range is. Well, the range, remember, is on y. So you notice that down here where y is negative, there's nothing there. There's no graph there. But starting here at 0, we start getting a point, right? We have an answer. We have a y value. And we have y values up until here. So in between 0 and 8, we actually have an answer, right? We have something there. Once we leave 8 and go up, the function's not there anymore. So our range is from 0 to 8. So we would write that as from 0 to 8. Now I'm including the endpoints because, as you notice, there's a little dot at the end, right? There's a point. I wouldn't necessarily write any x's in here, but I probably would somehow label that that was the domain and that was the range. Okay, so that's clear then. If you're talking about domain, you're talking about x's. If you're talking about range, you're talking about y's. Okay, so I moved my graph around a little bit, and now I have another function. So can you see what the domain is? So remember, the domain is x. So we would go from where x is negative 11, and I get an answer, right, all the way up until positive 11. So my domain is from negative 11 to positive 11. Now let's look at the range. The range, we start getting part of the function down here at negative 3. That's the endpoint. Well, the other endpoint is here at 0, but the function exists up here. So really, we have to go, even if it's not an endpoint, we have to go as far up as the function exists. So it's possible to get answers as high as 4. So 4 would be our upper limit. So we're going from negative 3 to positive 4. That would be our range. Okay, so we would write that as the domain goes from negative 11 to positive 11. The range goes from negative 3 to positive 4. So we're just looking at this graph and we're seeing where those boundaries are, where it actually exists. So where it exists, that's where we get our domain and range. So something else we can get from a graph sometimes is there's kind of a special case of a graph where the x-axis is time. These are very, very common graphs where we graph something as it changes over time, and you can actually get like a story from it. The y-axis can change to several different things. It might be distance, it might be height, it might be speed, it might be some percentage of something, but whatever it is, we have this, by using a graph, we can sometimes get an idea of the story. So one of the things that we often really do graph is the height of a child, right? So starting from when you have a new baby and they measure them, and then every time you go to the doctor, they're taking more and more. And if we look at that, a baby may start out here at, less than 2 feet tall, right? And as they grow, they may grow kind of slow, and maybe they'll have a growth spurt, and they'll get higher, but eventually they grow pretty slow, and then they level off, right? So, growth or height, that's a common thing to graph. We might graph the water level in the reservoir that gives us water. So, if it depends on when we start, say in the spring, water level's probably pretty high, and then as the summer goes on, it gets really dry, we use a lot of water, get way down. Maybe it goes way down if there's a bad drought. But then in the fall it starts raining, and it gets a little more, and snowing, and then when the snow melts off, we really get right back up there again, right? So lots of different professions look at these graphs over time. You've probably gotten them before if you use have a gas bill or electric bill, chances they may even send it to you in your bill, have a little graph that shows how it changes over time. It's a very useful sort of graph, and one that you really want to get used to looking at what's up here. You know, suppose I put speed. If this is speed over here, or velocity, you know, the graph can turn out looking totally different than you might expect. Because say we wanted to graph the speed that your car goes in the morning, right? So it starts at 0 because it's stopped. And then maybe you get going a little and you stop at a light, or maybe you have to, you know, maybe you stop at a couple of lights, maybe you have to sit there a long time, right? And then you get going, maybe then you get on the freeway and you get to go fast for a while and it's kind of steady. And then you get off the freeway and there's just a couple of little stops and then you're parked. You know, that could be this recording. You could, if you knew the speed, you knew the time, you could kind of even tell, oh, here, you know, here the speed was 0, so we stopped. Here the speed is pretty constant, so we must have been going somewhere where we didn't have to slow down very much. Of course, maybe freeway in the mornings is probably not that. You probably have to slow down often. But this, anyway, is a very useful way we use graphs in our everyday life. Okay, here's your quiz question for 3.3a. Give the domain of the function. So here it is. I don't know if you can read those little numbers on there, but each little tick mark is 1. So tell me what the domain is of this function and write it in interval notation and put it in Canvas in the quiz.